In this video, we're going to try a different resin. This is a rigid resin, rigid 4000, and we're going to see how it compares to the tough 2000 resin in some testing. Also, we're going to look at maybe producing some tools that will benefit the sewing machine repair community. Let's get started. Well, that escalated quickly. We've been a few weeks now of doing a little bit of research and development, and let's go through what we have here. We're going to start out with this one. This is our first ever printed prototype, and it looks pretty good. In fact, there might have been another one. I can't remember. No, I think this is it. So we have some problems underneath there. And this was printed with the resin printer that was like it was Anycubic's first version of 3D printer, so it was very old. I don't know, maybe 10 years old, 8 years old. A very old 3D printer that was for hobbyists and did not come out very good at all. Although, for a resin 3D printer, that's still better than what you might get from a filament printer. So that's our first try. Then we got the industrial grade, like professional resin 3D printer. And then here was our first attempt at that. So you can see a couple of issues with the supports, because this is all, printed on supports. Here's a picture of what it looks like when it comes out of the printer. You got all the supports on there that are holding this thing off the bottom. And actually it prints upside down, and I've got a little video where I'll show you a couple of layers being printed, and it takes a really long time. Each one of these took about 4 hours to print. Some of these, like these right here, if you can tell, they're a lighter, these three are a lighter color gray. So that's the draft resin. So you can see layer lines in here because this is just made to get a quick prototype made. And then, so it's like a draft. It's like your first draft, right? So the properties of this resin are not good to put into a sewing machine, but it is good to print it and see what you're going to get. So we printed a couple of these, changing different measurements each time, and also trying to figure out how to orient our supports such that we wouldn't get little support notches where they break off in the gears and that sort of thing, or along edges of the cam that are important. So then we get to this next 5 right here are ones that we printed in the tough resin, and we got very close with that. We just kept running into problems. So this one, for some reason, we got a comically large cam, so there is a issue with that, but that's, we're going to show everything. That was we call it number 3, even though, so we had a 0 and then we had like -1 over here for our revisions. But anyway, we went through that tough 2000. So this resin has been used to make hammers and nails, and I saw there's a YouTube video of a guy who printed a nail with this and then used a hammer that he printed with this to hammer it into a piece of wood. So this is tough stuff. This is tough 2000 resin, and so we did a couple of these until we got very close to what we wanted. This one one of the design things reverted, so our gear wasn't all that great on that one. The problem that we were running into with this tough 2000, although it's a very strong resin, is that the dimensional accuracy wasn't quite there, and I don't know if that's just because of me orienting this incorrectly or if it's properties of the resin itself, but we weren't getting the exact dimensions that we wanted. So then we had to wait for another delivery of a new resin. So this is a rigid 4000, rigid 4K resin, and this stuff is very good. I'm very happy with it. I'm also getting better with my game on where to put the supports so that I get a nice flat bottom. And the other thing is, I'm going to have to do some sanding on every single one of these that ends up going out the door. And so I wanted to minimize that sanding. So if I put all the supports on one surface on the bottom there, and then a couple of supports on the bottom of the actual gear teeth, then I only have to sand in one direction, which is where we come up with this one. This is our latest, I guess. It's not necessarily the last prototype, but it's the latest. This is very, very close. There's only one dimension that's not 100% correct on this one, the actual length, and it's only off by a fraction of a millimeter. So this may be good enough, and it is good enough for the machine that I have, but I'm not sure how other machines have this cam oriented and how it works in there. But I've got all the supports on the bottom and then on the bottom of these teeth, so it's easy to sand a little bit here, sand this flat on a sanding surface, and then it's good to go. So the only thing is we're going to shorten it maybe just a hair, and then we will try this in the machine. But you may notice there are some other pieces up here. So in the background, along with this, I'm working on a little kit that I could sell if you wanted to work on sewing machines. So this is an idea that I had based on my Navy career, and when we would work on circuit breakers, there would be certain dimensions that had to be just right. And you had what's called a go, no-go test. So if you put the go side in, it should go into that area. So in that case, it was like a gap. And then so you would put the go, no-go test in. So the go side, if the go side goes in, that's good. If the no-go side does not go in, that's also good. That means that the no-go doesn't go in, the go does. So your clearance is just right in that Goldilocks zone. And I've noticed working on sewing machines is that the presser feet, or not the presser feet, but the feed dogs, when they come up, most manufacturers, and I'm not going to say all because everybody does things differently, but for the most part, it seems like the spec is somewhere between 0.8 millimeters and 1 millimeter, where you want those feed dogs to come up. And so I made my own go, no-go test of 0.8 on one side and 1 on the other. So the 0.8 should be a no-go. So if you have no-go facing up, then that's the 0.8 side, and you put that down and you put the presser foot on top. You should not have this lift off as you're feeding, advancing the machine. Or sorry, for the no-go side, it should raise up. And then for the go side, it should not raise up. So the go side means you're good. So the go side has a 1 millimeter spacing, and the no-go side has a 0.8. Now this one was printed incorrectly, so I had to learn how to support and orient these correctly. Again, this is the Tough 2000. So this one was much better. This was my second attempt, go, no-go. And again, I wasn't real happy with the Tough 2000 and how the layers weren't as flat, and the dimensional accuracy wasn't there, and that's just because it could be because of my orientation, or something else, I'm not sure. But I did get a better print when I went to that, and I don't even know if you can read the go, no-go on there. But when you get to the rigid 4000, this is a very smooth part. This is a very nice part, and the accuracy is there. So you've got 0.1, I'm sorry, you've got 1 millimeter on this side, and you've got 0.8 millimeters on this side. So what you have is your feed dogs come up this way. So when you're at your 0.8, it should push it up a little bit and then come back down, right? Every stitch, it should come up, push this up off of the needle plate on the 0.8 side, and then on the 1 millimeter side, it should not. There should be enough space in here to where they come up and they don't push this up off the needle plate. If they do push it up, then you know your feed dogs are adjusted too high and they need to come down. If you're on the 0.8 side, which is your no-go side, if this does not push it up, then you're less than 0.8 and you need to adjust them up again. I'm learning how to 3D model things myself, And so this is my personal 3D model. This is one that I found online, and I've been using this. But what I wanted was one, first off, I can't sell this because this is someone else's design, but I wanted one that was shorter. And so I made one myself that's shorter. It's also got a smaller diameter slightly. But this is easier to get into some of those places, especially when you're just trying to get the needle plate off. And then you put a magnet, I put a magnet in the bottom, and so it holds that. So we are going to be working on a toolkit in the future. I've got to figure out where to buy a whole bunch of these bits so that you can have the same tools that I use when I'm working on sewing machines. Oh yeah, and I also forgot to tell you another part of this process. So when I pull these off the printer, I've got to remove the supports, and then I've got to sand the little nubs that were left over by those supports. So that's two operations we've got to do. And then the other thing I found is that in order to get the perfect inner diameter for this shaft that we're turning on, the printer is not sub-micron accurate, but what is one of these. So this is called a reamer, and you're reaming through basically plastic, and so this goes in here, and this reamer is exactly the right size for the shaft that's on this machine. So when this goes through, what you want is, you want this hole to be slightly small when it comes off the printer, so that when you put this through, it's going to take away just enough plastic to give you the exact perfect dimension to work on these every time, and that's what we've got. So this is the perfect dimension right here to be able to work for this shaft, and it's going to do that every time because we have this. So that's another thing that I have to do to every single one of these. So I'll end up putting this into a drill or putting it into a drill press and using it that way. This I'm doing hand just for our prototypes, but we'll get into kind of a scenario where we're an assembly line process to make these. All right, I am very happy with that. So the next step is to let this run for a little while on its own. So last time I did 2 hours. I think that's pretty good to do that again. All right, so that broke, and I just realized that may have been my fault. Yeah, that broke. See this right here? I did not tighten this after I set it. Yep, that still turns. So it moved in a direction that it shouldn't have, and it broke. Okay. We'll keep going. But this is glass fiber reinforced resin, and yeah, I don't think you're supposed to cram it so that it can't turn. So let's recap, because a lot of stuff has happened, and I'm not sure just how well I was able to edit this video. So let's kind of recap where we're at. So we have gone through and we've designed our models, and then we've come up with a design that is as good as I can get with the dimensions, that it looks really good. Then we also worked on our supports to make sure that there would be very little sanding required when we get these parts out, because if I'm going to be producing these, 100 at a time or so, I need to not be spending many hours getting each one ready. And then we had the two contenders. We had the Tough 2000, which is the gray resin, and then we had the Rigid 4000, which is the white resin. And after running these for a couple hours in a machine, what I've noticed is that they both work really well. So we had some problems where there was some cracking the pins, but then we found out that's because I just installed it wrong. So this is going to be less strong than a full metal part, and we understand that. But it's going to get your machine working again. And this resin can work and can replace that. We just got to make sure we install it correctly. And I'll have a follow-on video that talks about installation before we put the listing live. So when I'm looking at these parts, what I notice is that on my Tough 2000 parts, the gray resin, they all look pretty good after they come off the machine. You have very little wear on those parts. Then when I look at the rigid 4000, I'm starting to notice that each one that I've done testing on has had cracks in this really thin portion right here. So this is very thin, and we have cracks on the back where it's really thin. And that's something that we know that this rigid is prone to being more brittle than the tough. So right now I'm leaning towards this tough, and we're going to do some destructive testing next to see how well these hold up to a little bit of something that it may not see every day inside of a sewing machine, but I'm just curious. This may not end up having bearing on which one I use, but I really want to hit something with a hammer, so let's get to it. So what I have here are two fresh parts that have not been in a machine. These are the most recent revision of our drawing. They've been printed the right way that I like, and so we're going to give them a try and see how they handle a little bit of mechanical adjustment. Alright, we've got the plastic hammer first. So this one should be fairly nice to these. We're going to get... Don't try this at home, kids. So we're going to give this a nice little bonk right there and see how it does. Hopefully it doesn't fly into a million pieces, but I've got some iPro on to keep me safe. Okay, so that was... Now, if you wanted to know how hard I hit that, look, we've got some indentations in that board. So we hit it pretty hard. We hit it hard enough to put a dent in the board there. And that came out without an issue. So let's try another one. We'll put a new spot just to see if we get... So this is our rigid. And it's gone into a million pieces. That went everywhere. That went everywhere, and you can see, I mean, it left a pretty good hole or divot, and then it also divoted over here, so that thing immediately just exploded. Okay, well, without going on to the next step, I can already tell you that the Tough 2000, I believe, is where it's at. I don't know if I'm going to be able to find those pieces. But, alright, we'll try. We'll see what we can do this Tough 2000 here with the next hammer. So we'll try the dead blow hammer. We're going to try the plastic end first. This has a lot more weight to it. Alright, so again, we have a nice indentation under there. And we have a fully intact cam gear. I'm liking this stuff, this resin, this Tough 2000. Alright, well this has two sides on it. We can't, I mean, we just can't leave it at that, right? So, let's go ahead and give this a whack with the brass end. And we found a new spot on our wood board here. Wow. So I think I hit that one on the cam, mostly. Wow, I mean, I'm impressed. I can't believe that the rigid one exploded on me. And this one has yet to even show much of a mark. There's a little bit of a mark here. Should I do that again? Are you kidding me? Okay. I mean, there's only one way we can go from here. Yep. We've got a bigger hammer. So let's give let's give this one a try and see how Tough 2000 holds up. Now we got some damage. We got some pieces. Yep, that's coming off. But yeah, if you're thinking I'm not hitting this hard, wow. So that wouldn't work anymore. I'm curious. Let's see if we've knocked our dimensions off. Wow. Okay, still good there. Yeah. So where the teeth are missing, it's lower, but it's not. It didn't deform the part. That's exactly where those dimensions should be. That's crazy. It won't break. I can say that I'm very happy with this Tough 2000 resin, and it is very tough. So I think that's what we're going to use. We were able to cause this to break, but it took a lot of force, and it didn't explode like the other one did. There's a piece. I found one. So we're going with this resin. We're going to sell gray. Yeah, so we're going to have these up in our store very soon, if not already, when you're watching this video. So how do you make a part that doesn't exist? Well, pretty easy. You just find somebody to make a perfect 3D model of it. You buy yourself the very expensive engineering 3D printer. You 3D print some parts in various resins, find the resin that works the best, test it for a few hours in a machine, make many prototypes and test all of them, and then you're pretty much there. So now that we have this new tool in our workshop, the 3D printer, we may be looking for other things. One thing I'm looking at is making flexible parts. So they have a flexible resin. This is not a part for a sewing machine. This is a sample part that they sent me. And this is kind of flexible. I might be able to make some of those rubber tires that are hard to find on the internet. I might be able to make whatever size rubber tire I want to make with this machine. The only thing that I don't like about these things is that you don't get to change the color. So what it is what it is. And if you see my other items, you know I like to change the colors. So anyway, thanks for watching.